This is an Intel P4040 24-pin 4-bit microprocessor from 1974. We got it off eBay for 60 bucks. And it's one of the great grandfathers of the modern chip. And I'm holding it because we've been doing a deep dive on the current state of American chip manufacturing, which, if you've been paying attention to the news lately, seems pretty bleak.
When we ran into chip shortages in 2021, into COVID, those chip shortages made everybody step up and realize it hurts everything from manufacturing appliances to cars.
But then I came across an article about how not a startup, but an older, more established company might be the key to saving American chip manufacturing. That company is Intel. If you haven't noticed, there are chips in a lot of things these days, almost everything. And there's been a lot of discussion around America's dependence on the Taiwan Semiconductor Manufacturing Company, otherwise known as TSMC, especially in today's gold rush of AI. If China were to take Taiwan and thereby TSMC, military experts typically agree that the opening chess moves of a military conflict over Taiwan would be about one thing: speed. This would be a war fought, ironically, with a lot of chips. Precision missiles, satellites, and drones all run on advanced semiconductors. Clearly, this is something we need to be paying attention to, and it's something that contrary research has been diving deep into. So I talked to Kyle Harrison about the recent article, Chips for America, Building an American TSMC.
We started out by looking at new ways of building semiconductors, whether that's new architecture, if that's AI-specific chips, or it's fundamentally different types of computing.
So what options do we have to bolster and protect American chip manufacturing capability? Option 1, support a startup to build an American foundry from the ground up. But how realistic is that?
Can we build it from scratch? And it's there's something that's called Rock's Law, which is coined by Arthur Rock, where it's basically this idea that the cost of a semiconductor fab will double every 4 years, and that's largely been true. It's exorbitantly expensive, maybe $20 to $30 billion just to turn the lights on, and that's things that are really complex, literally the most complex things that humans have figured out how to do. Technology like EUV, these are machines that can cost $300 or $400 million a pop. Clean rooms that are 1,000 times cleaner than a typical surgical suite. So building it from scratch is really difficult. There's no startup that's going to go out and raise, a $30 billion seed round just to build a fab so that they can raise a $20 billion Series A to be able to go try and put it to work. It's just not going to happen.
America once made nearly all of the world's chips, but over the last few decades, that expertise drifted overseas. Today, tens of thousands of jobs in chip manufacturing are sitting empty. It's a little embarrassing, honestly. The chip was born in America, and now we don't even know how to make them. And that brings us to option 2. Theoretically, we could borrow TSMC, but protecting Taiwan to keep it independent is complicated. A recent estimate by the Institute for Economics and Peace projected that a full-scale war over Taiwan could cost the global economy more than $10 trillion, far eclipsing the economic damage from the Ukraine war. Even a more limited Chinese blockade of Taiwan could cause a 2.7% drop in global GDP in the first year alone. And let's not forget all the people that would be dying over chips. But good news, TSMC is already coming to America, Arizona specifically, just north of Phoenix. They have just completed building the most advanced chip fab on US soil, a 3.5 million square foot building with some 2,000 employees, and a plan to produce 4nm chips at a rate of 20,000 wafers per month. And Apple has already signed on as its biggest customer. But will it be enough?
When you look at Taiwan and their sort of reaction to TSMC's investments in Arizona, they're very deliberate about not wanting that cutting edge capability to be exported to the US. But the reality is that to get access to cutting edge research, Taiwan is very protective of keeping that in Taiwan. They call it their silicon shield, that they believe that the reason they've been protected from a Chinese invasion is because the US and other countries are so dependent on Taiwan for semiconductors. So the Taiwanese government is very deliberate about making sure that quality of the research and production that's getting outsourced to those plants, they're trying to keep it as far away from the cutting edge as possible, while still not feeling like they're taking away from what they promised the US. So we can get a lot from TSMC, getting to that cutting edge capability. Taiwan is heavily incentivized to make sure that we don't get that.
Semiconductors were invented and innovated on in America, but we gave it away. What's the story there?
That's what happened in Asia, where we were manufacturing so many of our chips that the cost curve changed. You already had way lower cost of labor. You add on to that you're giving them the vast majority of our volume, that they're going to get so much more effective at manufacturing chips. And then eventually gets to the point where we literally don't have that capability internally. So it's okay, where in the US can we go to buy cutting edge chip capability? And literally, I kid you not, the only option is Intel.
This video is sponsored by SBS Comms, a longtime supporter of this channel. SBS is a PR firm focused specifically on technology companies, from startups to industry giants. They speak the language, know the reporters and the landscape, and deliver results that matter. If you want to spend more of your time focused on building rather than storytelling, reach out to SBS today to learn how they can help you with your storytelling efforts. Speaking of industry giants, let's get back to the story of how Intel could save America.
There's a great quote from the original founder of AMD where he said, "Real men have fabs. We build chips ourselves." Basically, everybody has given up on that.
Wait, but why is that? Why did we give it all away? And to answer that, let's look at the complexity of building a single chip. The first ICs had around 10 transistors. The NVIDIA Blackwell from 2024 has 208 billion transistors. That's roughly a 10 billion-fold increase in transistor count over 60 years. A chip today has 10 billion times more transistors than the first one did. Basically, as transistor sizes keep shrinking, they become exponentially more complex and expensive to manufacture. The prevailing belief was that the US could focus on chip design and higher-level R&D while letting cheaper overseas foundries handle the low-skill manufacturing work, which has been a common theme for manufacturing over the past 2 decades. Okay, back to Kyle.
And so when we stepped back to think about what is the most important element for us to drill into and really understand, it was, what are we going to do about this sort of like double-edged sword? If there is a private market solution, if there is a startup that can make a dent in the problem that we have articulated, what is it?
Intel was founded in 1968 by Robert Noyce and Gordon Moore, who along with Andy Grove, built it into the company that powered the personal computing revolution. After inventing the microprocessor in 1971 and winning the IBM PC in 1981, Intel became the dominant force in computing by locking in the x86 standard and perfecting advanced semiconductor manufacturing. Intel relentlessly drove Moore's Law forward. By 2011, it was the first to mass-produce 22-nanometer chips using 3D transistors. So, what happened? Well, in the words of legendary Intel CEO Andy Grove, not only did we lose an untold number of jobs, but we broke the chain of experience that is so important in technological evolution. In the 2010s, Intel stumbled, missing the mobile revolution when it lost the Apple iPhone chip contract to ARM-based designs. It fell behind Taiwan's TSMC and Samsung in chip manufacturing at the 10-nanometer and 7-nanometer scale. And today, Intel has lost ground to NVIDIA and AMD in the AI chip surge. Even Apple is no longer using Intel silicon. Since 2016, TSMC has produced all of Apple's chips from their own designs. Beyond these technical missed opportunities, Intel also suffered from a cultural shift. Over time, the company moved away from its engineer-led roots, the kind of culture Andy Grove built, toward a management-driven one. And some say that change led to complacency and slower execution, a lack of technical rigor. Despite its decline, Intel remains uniquely important today. It is the only American company still capable of manufacturing advanced chips domestically at scale. Before 2021, Intel only manufactured chips that it designed itself. The launch of the Intel Foundry services marked a major strategic shift. Intel now builds chips for other companies and competes directly with TSMC and Samsung in the contract manufacturing business. So today, Intel has 15 wafer labs in production worldwide at 10 locations. Production sites include Chandler, Arizona, Rio Rancho, New Mexico, and Hillsboro, Oregon. This global wafer capacity report from 2024 notes Intel's production was 817,000 wafers per month. A single 300mm wafer can produce anywhere from 100 large high-end CPUs, if every chip is big like a server processor, up to several thousand small chips like microcontrollers or power chips. But as of 2019, Samsung's capacity is around 2.9 million equivalent wafers per month, and TSMC trails just shortly behind at 2.5 million wafers per month.
Over time, they've had 4 different leaders over the course of 4 years, and that title has gone from president of Intel Foundry to the general manager of Intel Foundry. And even Intel Products has a CEO of Intel Products. Why is there not a CEO of Intel Foundry? Why are they not leading with a vision of what they can accomplish? Those are the fundamental things that Intel needs to change. And until that happens, things like the CHIPS Act, it's like you can pour money into a problematic engine, but you're not going to get out better results just because they have more capital flowing to the top of funnel. You really have to unpack the pieces and solve the problems before you can then invest in capability. But Intel is so close. Like in the piece we map out sort of, when they've launched different nanometer scales of chips. They're the only one that's still the fight is not over. It's not like they're multiple generations behind. There's 3 core components of Intel that need to be dealt with. So the first thing is that Intel went through a pretty massive transition from engineering to managerial leadership. I think it was in 2005, they had their first CEO who was not an engineer by training. And then they basically went through about 15 years of financialization. This was literally the peak of stakeholder capitalism, of like maximizing shareholder value and massive stock buybacks and financial engineering. Very little focus on maintaining cutting edge engineering capability. When Pat Gelsinger joined as CEO, he really emphasized this idea of we need to bring back the geeks. We need to put engineering back as the sort of core focal point of the company. And while that happened, slowly but surely did build back a bigger focus on engineering culture. There was also the element of that they needed to be able to incentivize their teams and systems and things like that to really focus on high quality output more so than things like profitability. And that brings you to the second point, which is Intel has not only a business model and a mentality and a board, but also an investor base in the public markets that is very, very focused on short-term earnings optimization. Like they spent 15 years curating that investor base to solve for how can we make sure that Intel is as profitable as they possibly can be. When they started to break out Intel Foundry as a separate P&L, people realized, man, that how much Intel Foundry was kind of a loss leader for them. And there were literally activist investor lawsuits against the board, believing that they had misled them about the health of Intel because they had kind of obfuscated how much money the foundry cost. And so it's fundamentally the wrong investor base. But even if you change the culture, even if you change the investor base to really focus on this sort of growth and innovation over cost optimization, you still end up with this core problem where there is not visionary leadership at the company.
US policymakers have begun directing support its way. For example, Intel secured $7.9 billion in CHIPS Act funding for a new set of fabs and R&D, plus about $3 billion in DoD contracts under a program called Rapid Assured Microelectronics Prototypes, or RAMP. The government is also investing in a bunch of different options with the CHIPS Act, and there's an argument to be made for diversifying our efforts.
Intel is big, they fab, but there's another newer, maybe faster company, albeit that doesn't fab, but knows a bit about it, that has 40 times the market cap Intel does, NVIDIA. Why can't they do it? And they still have their founder leader, who I think, I don't know, I guess I get confused why Jensen doesn't think or talk more about doing this. They certainly could afford it, and compared to anyone else other than Intel, they seem like the most well-positioned company to even think about doing this.
I think absolutely there is a world where NVIDIA could do this. Like there is a core dependency that they also have on TSMC that is problematic for them. There's a lot of geopolitical problems for them in terms of the dependence that they have, not only on TSMC as a manufacturer, but China as an end market. There's a bunch of complexity that gets solved if NVIDIA was producing its own chips. Whatever it is, like whatever process we take to be able to give Intel the things that it needs to be the, America's foundry that we need it to be. Like I'm open to any of those things. Like I'm not here to say, hey, I think it's got to be these folks and not these folks. It's got to be this money and not that money. Like there's a lot of pros and cons to a lot of different approaches. And so I don't think that we're necessarily trying to say this is the only path forward for doing this, but more so these are the things that need to happen in order to make this, American foundry possible. The reason that AI is so critical is not just because it's great and we all want better chatbots, but it's because in the pursuit of something like AGI, as AI gets better and better, its ability to then turn around and support us in the pursuit of even better AI, it all compounds. And if we get cut off from the access to cutting edge AI, then we get cut off from the future. That's why this is so critical. It's not just because we want to pick another fight over a commodity that we're all excited about financializing. It's because it is a fundamental element for any of us to continue to build the future.